Good morning. We're back. And we're going to try to see if we can't overcome. We're going to try to see if we can't overcome day 8 today. We'll see. We'll see how this goes. Yesterday went well, but yeah, we didn't get it done. Today we're gonna try to get it done. First things first, we gotta take care of the housekeeping stuff. Good morning, Stefan. Good morning, Oblivious. We are back. We're gonna try to take care of day 8 today. Let's see. First things first, we need to do the housekeeping stuff. So Discord event. Excuse me. Excuse me. Man, today's the 16th. That's crazy. Shit goes by fast. So fast. Let's see, apply. Alrighty. Okay, we got the Discord event created. Now we need to... What else do we need to do? I think that's it. Oh, we need to pin a message. Excuse me. I didn't mean to burp. Good morning, Arvin. How are you doing? Glad you're here, man. Let's see. Good morning. We are going to get caffeinated and not let day 8 eat us. If you are new here, try commands for more context. I'm mentally strained as fuck, cannot get myself to grind any further. Hey man, there are definitely days like that, dude. I'm sorry you're having one of those days. Or one of those periods. You just gotta, I mean, the only answer to it is just to keep putting one foot in front of the other, you know? Rooting for the completion. Well, I appreciate that, Oblivious. Thank you very much for the encouragement. I thought about this problem all day yesterday. I was halfway debating last night after we put the kids to bed. I was halfway debating streaming last night again. But then I was like, no, because if I do and then it goes late, then I won't be able to get up in the morning because I'll be too tired. So I tried to be disciplined about it. So we're gonna see if we can't overcome today. I honestly don't know if we'll get through part 2, but if we could just get through part 1, I could do part 2 later today. Okay, so admin to code. I don't even remember really where we left off. Basically, where we left off with this problem was I have my coordinates parsed. I have my distances calculated, and I have my distances sorted. And so now what I need to do is I just need to process and build up the circuits. So I have one more idea before I do the brute force thing. So I know with 100% certainty that if I actually build each individual circuit, I can solve this, right? So if I actually follow the connections and create a graph, and basically use kind of like a breadth first search or a depth first search to walk this graph, I can build up the individual circuits. But I have one more idea that might, I think it's what I was trying to do yesterday, but I couldn't articulate it. We're gonna see. Go test. That just runs forever. Let's go into day 8, main.go. Start diving in. Me and Steven both just woke up. Oh, dude, I mean, every day when I start the stream, I've just woken up, you know? I literally, I've been up for all of 20 minutes at this point. Kind of a pimple right there. It hurts. Let's see. Dabu. I feel the same way. I've been studying for exams all this weekend. I still have 2 more. I'm wishing you the best, man. Sending you all the positive vibes. That is not an easy road. I did some adjusting to my network setup, and the stream is playing smooth and has less than 3-second delay. Fascinating for my situation. Well, nice. Well, I'm glad the stream is coming through on your end well. That's awesome. I gotta eat this orange real quick. Okay, so I have, we're gonna do type, circuit, I don't even know if circuit's the right word. I don't know what to call this. I'm just gonna call it an item. I don't know what to call it. So it's gonna have, this is gonna keep track of, so basically this is the idea that I had yesterday, and I just couldn't figure out a way to express it. And I still don't think I quite express it. So here's what I'm thinking is I'm basically going to keep track of I'm basically going to keep track of just whoops. I'm going to keep track of this, and I'm going to keep track of this, right? Which, what this does, if I keep track of things like this means that, delete all this. This means that it's very easy for me to figure out if given 1, it's very easy for me to figure out, oh, who's your parent 2? Oh, who's your parent? Or it's like, oh, who's your parent 2? Great. Well, who's 2's parent? 2 parents is 6. 6 parents is... So it's very easy for me to, Cameron, to resolve up my chain if I keep track of this. And then at each step in my chain, I can also keep track of the size. So it's basically representing the graph, but representing it according to whoever's each box's parent. That's how I'm representing it. So each box has a parent, and if we resolve the junction box to its parent, and we resolve the parent to its parent, we can eventually terminate at some point. So what does that look like in practice? So this is going to have parent, which is going to be a junction box, and then a size. Which makes this map I don't really know what to call this, so I'm just going to call this items map. Because I don't really understand what this represents. And then we'll do items map. This will be our box. Sorry, this will be our box, and this will be mapped to an item. And this item is going to tell us 2 things. This item is going to tell us, whoops, Copilot, don't help me. This item is going to tell us who this box's parent is, which is always going to start out as the box itself. And then this is also going to tell us the size of the associations, which will always start as 1, right? Because it basically every circuit starts with itself. I forgot to check to see if we have any new members. Hold on one sec. Let me make sure. I don't want anyone getting left out. Nope. Okay. We're all good. We're all good. You don't have to change anyone. Just manage yourself around them better. That's great advice, Stefan. And because honestly, the truth of the matter is, you can't change anyone, right? Like, not directly. I mean, you can be a force for good, you know, but you can't change people. You can't control others. Good morning, Gunhighs. You changed me. I hate Go now. Somebody should most definitely make a .NET Fuck the World t-shirt. Okay, so my idea now here is this. Oh, this actually is wrong. This should be junction box. So now that we've registered all of our boxes as part of our items map, we should be able to what do we do? So for each one of these, we still need the limit. The limit's something we're going to pass in. So we still need a limit. We're going to loop over all our connections. And we basically I guess, are going to process through, and whenever we find a box, well, first what we need to do is we need to figure out if circuits can be connected, or can I combine things? Um, I think is what we need to do. Not can we combine things, let's actually combine things. So what is that going to look like? What that is going to look like is for every connection, we essentially need to walk So what we're basically going to do is we're going to find the root of each potential circuit. So if we treat each connection as potentially belonging to its own circuit, we can do like what can we do? I guess we can say root, let's say start root equals connection dot start, and end root equals connection dot end. And then what we need to do with those is we need to actually find them. And how would we do that? So I guess let's just start with the start. I guess the first thing we're going to do is we're going to run basically kind of like a while loop, right? Where we're just going to iterate through this map of items, always going up the chain of the parent. Excuse me, up the chains of parents until we find what we're looking for. Yeah. This probably should be a separate function because we're going to have to use it multiple times. We're going to have to use it every time we have to check for a root. But I think what we'll do is we'll say the start root equals the connection dot start, and then we'll say while basically while the, or not while, sorry, this is not .NET. We are in GoLand. You can share different options for others, but it's up to them to choose what they do and are. Yep, 100% oblivious. You guys are some wise motherfuckers, I tell you what. So we'll say while checking the map. So we'll say, okay, if we use the items map and we look up the start, this particular entry for this particular position, and as long as its parent, right? Where are those fields coming from? As long as its parent does not equal the start root, right? So basically this is detecting if we've gone in a full circle, right? Like if we've went up the chain and now we've completed the circuit, or at least we've walked, I guess at this point we've walked up the chain, right? So if we start at the start root, and as long as basically the size of this entry is basically not the original entry, we want to keep looking up and following that chain, right? So if we're looking at that drawing, we're going to say, okay, you give me 1. That's the start connection in this point. Let's just say that's the start. I'm going to look up into my, or let's say 2. You give me 2. I'm going to look into my entries here, my items, and I'm going to say, oh, okay, 2's parent is 6, right? And then I'll reassign the root to 6, and then I'll find 6's parent. Well, if 6's parent is itself, then stop. That's basically what I'm doing. Who subbed? Aussie? Aussie number 1. Thanks for subbing. Appreciate it. Very kind of you. Yeah. So what do we need to do here? So I guess then what we'll do is we'll do start root equals items map start root dot parent. Yeah. So basically walk it up, and then once we walk up, we also would like to in the future we basically want to save ourselves this misery of having to do this every time. All right, so let's separate this into a function. This needs to be a separate function for sure, because we're going to have to repeat this at least twice every time we work on a connection. So I'm going to have a function called I guess for lack of a better word, I'll just call it find, right? And so find will take in a particular junction box. Like so. And it will basically do this. And we'll call this the root. So maybe that's, so let's say this is called find root. That's what we're going to call it. We set the root to the box. We set this to box. Sorry. This becomes a root now. Now there's one little thing we can do here, because you can imagine this is going to get, this is going to get, I guess we'll also pass in the items map. As the circuits get larger, this find function is going to take longer and longer to run. So the items like this. And the thing is, we don't actually need to walk this chain every time, right? So what do I mean by that? What I mean by that is we can actually shorten. So this is going to return the root junction box. Oh, I don't want to reassign. There we go. So what I mean by this is Since what we're doing is we're basically walking up the chain of junction boxes. Where'd my since we're walking up, so if you give me 2, and I'm gonna walk up 2 to find 2's parent. I guess actually this entry would look like this, wouldn't it? Or would it look like this? But you can imagine if I had multiple levels, I really don't care about whose 2's parent is. I care about who 2's root parent is, which means once I find 2's root parent, I don't need to keep refinding it again and again and again. I should be able to for lack of a better word, I should be able to compress the circuit so that it doesn't require that many iterations, right? So like in this example, right? So let's say, right, 6's direct parent. 6's direct parent here is 5. But I don't care about 6's direct parent. I want to know about 6's root parent. So once I loop through here and find that 6's root parent is 4, well, I can just set 6's parent to be 4. It doesn't need to 6 doesn't need to care about 5 anymore, at least for this problem, because I don't actually care about. See, that's the trick with this question, is I don't actually care about who's in the actual circuit. I just care about the size of it, which means I don't really need to resolve every individual link of the chain or know every individual link of the chain at the end. I just need to know the number. And so then in our find method, we can do that, right? We can, or we should be able to. Yeah, I think we should be able to do something like this. We can say, let's do current equals are the box that we were originally given, and we can say for current does not equal root and then we can say item equals items map, just give me the current one, give me the current entry, and then the next is item dot parent. Why are you mad? Oh, I can't stop writing triple equal signs for some reason lately. So we have next, and then what we're gonna do is we're gonna say, okay, great, your items. Yeah, we're just basically going to represent the fact that, hey, guess what? You're actually your parent is actually the root now, and the current is going to become the next, and we're just going to carry on through that loop. I think it'll be interesting to actually trace this through. Okay, so that means then instead of doing that, we should be able to do find. Oh, whoops. The other thing we need to do is after we set that, we need to also set it here. So we need to say items map at current equals item. Right? Because this is going to give us a new item. And so we have to update it. So then we should be able to do find, whoops, not in there. So what we should be able to do is we should be able to come up here and we should be able to say find root for the connections start, and for the end root, find root of connection end. So initially this is just going to find itself, right, the first time through. I believe that's when it's going to happen. So let's print this, format.println. It's going to be start root and end root. Hey, Titano. Good morning. Yeah. So this is basically, at this point, they're just finding themselves. At this point, there's nothing special happening here, because we're not actually like wiring the connections into circuits at this point. So that's what we need to do next. Is now we're going to take those roots and we're going to see if we can union them together, or connect them together. So I guess the first thing we want to do is we want to say, hey, if start root equals the end root, if these are the same spots or same boxes, continue, because you can't tie a junction box to itself, so that's not going to work. So then what we're going to do is we're going to come down here and we're going to say, okay, great, so we know we have two different start roots and end roots. Wonderful. So we're going to access the, I don't know what the right term is. This it's not really it's not really a circuit, right? I mean, I guess it is kind of what we're using to represent our circuits, but what we need to do here is we need to get start item equals items map, and we need to look up start root. Then we need to do end item, look up items map, end item, or no, end root. Stefan, quick question for Steve. What's the difference between a process and a thread? I don't actually think I can answer that question. I guess if I so when I think of a thread, I think of a thing that can handle some work. And when I think of a process, I think of something that can potentially access multiple threads. But I don't actually know if that's correct. We could ask Gemini. I'm sure there's a proper computer science-y answer to that question, but I don't think I know it. What if you were streaming and one of your chatters asked you what is a process versus what is a thread in the context of computers. I feel like I'm being interviewed. Stefan, process has its own memory. It's like the whole workspace, and a thread is within that process, sharing memory with all the other greats inside of it. Thread is a part of a process. Oh, okay, so I sort of knew what I was saying. Threads are the employees. Yeah, that's what I was gonna say. That was actually the word I was gonna use. Was I think of a thread like a worker. Like a thread is like something that can go off and do a task, but a process can like have multiple tasks that need to be done. Mike, thank you for subscribing. I appreciate it. But I like the pizza shop analogy. Yeah. Well, Stefan, I failed your interview this morning. Okay. So given a connection, we take the two ends of the connection and we resolve them to whatever root circuits they belong to, right? Because that's basically what my map is keeping track of. Is I'm keeping track of the root things they belong to. So now what we can do is we can actually get the items for those particular root boxes. And the reason we need to get this is because we need to make sure we keep track of the size of things, and we're going to use the size to determine what goes to what. So we actually want to always take the smaller circuit and tie it to the bigger circuit is what we want to do. So if start item dot size is less than end item dot size, we're going to do something and we'll continue. Otherwise, we'll have the default case, which is they're just going to be the inverse of each other. So in this case, end item dot parent, end item dot parent becomes the start root, and the size of the start item gets increased by the end item's size, like that. Actually, I'm going to make this an else block because we need to, after this is all said and done, we actually need to then reassign these things. So we need to say that. So the inverse of this would be what? The inverse of this would be start item dot parent becomes end item, no, end root, this. And then the end items dot size gets increased by the start item dot size. So again, this is the unioning of the different circuits together, right? So this is, we found we have 2 over here. We found, let's say we found the start is connected to a circuit of size 2 over here, and we found the end is connected to a circuit of size 1 over here. Okay, great. We need to stick those together. But we're not actually creating the full circuit. That's the thing, is like we're not actually creating the full complete. Like I couldn't, with this implementation, I can't actually tell you all the links in the chain. I can just tell you that this thing belongs to this root circuit, and that root circuit has a total number of junction boxes in it. Yeah. So then once we've done that, we should be able to then we should be able to then what? I guess what should we be able to do now? See, Stefan? No, I'll just start asking these random questions once per stream, so eventually you get educated as fuck. Sounds good. Sounds good. Keep me on my toes. I like it. Well, let's just print out what we end up with. Well, yeah, let's actually see if this actually runs. So let's just print the items map. See what happens. See if this runs. My hope is that we're going to see... Oh, whoops, my... Everything looks like it only has a size of like 1. Size of 4. My viewer fetcher broke. So let's see, CD. Remove the token. .NET index.cs. Good morning, Rahul, I think. Thanks for subscribing, man. I appreciate it. Huh. I wonder why it failed to refresh. Failed to refresh. Oh, there we go. I was like, what's going on there? Oh, it's cached. That's why. Oh, my Posh had cached the result. Okay, so I guess what I need to see is let's loop over the maps, and we'll say for key value range over items map format dot println. I'm just interested in what the size of these things are. Oh, that's the wrong. That's the wrong. That's the wrong place to run that. So let's do Command 8. So we have 2, 5, 4. Okay. So we have a lot of 1s in there, actually. That's interesting. So what are the sizes we would expect? So it looks like it contains 5 junction boxes, or 1 circuit with 5, 1 circuit with 4, and 2 circuits with 2. So I have 5, I have 4, and I see 3 circuits with 2. And 7 circuits which contain a single junction box. Multiplying together the sizes of the 3 largest circuits produces 40. So I'm curious, why do I have so many extra? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh, that's because we registered. Yeah, that's because when we initialized the items map, we actually added all of these. So if we were to actually sort these, so let's say circuit sizes equals slice, and we were to say, okay, give me all of dot append v, like that, dot size, and then we were to say, okay, great, we have all our circuit sizes, now sort it. How do I do that? Slices dot sort, I think. Sorts a slice of any order type in ascending order. We want to sort in descending order, though, don't we? I guess we can do that. Pass in the circuits. And we can say function. This gets an A. This gets a B. Returns an int. And then we can say, great. We want to do descending, so we'll do B minus A. Now let's format .println, and let's print the circuit sizes, and now they should be in descending order. Any jolly Christmas enjoyers? Hey man, I'm right there with you. Look, I even got my mug's even on theme this morning. The Grinch. Hey, what's up, Thunder Deer? How are you doing? Good to see you. Arvin, not hired. I wouldn't be hired. I'm telling you, I wouldn't pass the snuff for a lot of like quote unquote computer science educated developers. I mean, in every interview I've had, I've always been super honest about that, you know? Like I always do my best in the technical portion of interviews, but I'm always very honest that, you know, I'm not a formally trained computer scientist. I don't have that background. Everything I know, I've kind of self-taught. But I always tell them, like, I'm very confident that I can solve problems. I just might not always have the right language or the right parlance. And I'm always happy to be educated, you know, about the formalities about what I'm doing intuitively or what I'm stumbling upon intuitively. And that sometimes is received well in interviews and sometimes is not. Okay, so now we can take the first 3 and multiply them together. So I am going to call this yeah, I am going to call this, instead of items map, I'm going to call this gonna call this circuits map. And so this is a circuit. This is essentially how we're representing a circuit. We're representing a circuit as the root, and the size of that, whatever that is associated with that root. And then the key is just happens to be whatever junction box we're looking for. Okay. What's the last part of this answer that we need to get to? We need to get to 40. So how do we get to 40? We have to multiply together the sizes of the 3 largest circuits. So 5, 4, and 2. So this is where we just say, okay, great. I guess I can check and I can say if circuit sizes is less than, or the length of circuit sizes is less than 3. Panic, not enough circuits to answer, or I'm just gonna say not enough circuits. Otherwise, we're gonna return circuit sizes 0 times circuit sizes 1 times circuit sizes 2. Return 40, expected 1. No, we expected 40, I just didn't update my test. So this right here, this is exactly what I was trying to express yesterday, and I could not figure out the way to represent it. I initially tried to represent it by doing this, where I had a parent on the connection, or on the junction box itself. So originally I tried to do this, which was like a pointer to another junction box, which just felt weird. But this is the data structure that is the key, because this is what allows me to process Jonix Beats. Thanks for subbing, man. Appreciate it. Good morning, Danny. Good to see you. All right, let's try main test. Let's hit over to, let's change that to 40. So this should pass. Hell yeah. Now we need to try with our actual input and see what we get. Honestly, if this doesn't work, this is going to be really, really defeating. Yeah, it's going to be really defeating. Solve part 1. Yeah, solve part 1 with input. I wonder how performant this is, though. I mean, it should be pretty performant, because the fact that I'm this is the part where I save a lot of time. So in my find method, this saves me a lot of time, because it basically, what it does is it means whenever I do, for any given box, so if a box is 3 steps away from the root, what I'm calling the root circuit, that allows me to avoid having to go to every parent in that chain. I am just shortcutting and saying, oh, well, I know this guy resolves to this root up here, so I'm just using that as the parent. So that saves me a lot of time. It'd actually be interesting to remove that and see how much longer it takes to run. Solve part 1 returned 8. That seems not right. Oh, because the limits are different. right? The limits are not the same. Your list contains many junction boxes. Connect together the 1,000 pairs of junction boxes which are closest. And they only wanted the 10 shortest. So we were actually increasing this by a couple factors. So we need to update the signature of our solve method. So we're going to add num of connections. Oops. Then that means in our test code, so this is going to be 10, and then here it's going to be 1,000. Wow, that was really fast. Solve part 1 returned 183,000. So let's see. Drum roll, please. Drum roll. Okay, ready? Damn it. That's not the right answer. Your answer is too high. If you're stuck, make sure you're using the full input data. There are also some general tips on the About page, or you can ask for hints on the subreddit. Fuck. So we're back to this problem where it works for the example but doesn't work for the input. So we know that's too high, so I guess that's a piece of information we should probably stick with. Man, this sucks. Oh, no, sorry, -1, and then we know max. This, so we know if result is greater than or equal to the max, solve part 1, return D. Value cannot be greater than %D. Alright, so well, we at least know that. We at least learned something. Value cannot be greater than 1,000. So I guess let's print out what our sizes look like. That might be a good place to start. Circuit sizes. So the vast majority of things are 1. Which I guess is what you would expect. I'm not really sure how to troubleshoot this, if I'd be honest. When I was first solving it, I created my own input of various edge cases I was aware of. Well, shit. I'm not aware of any. Good morning, Wilo Gamer Pro. Yeah, this is the same problem as yesterday. We're actually making progress, though. We got it to work on the example input, but we haven't gotten it to work yet on the real input. So I guess that's a good thing. I don't even know how I would figure out edge cases here. You know, these are just numbers to me. Um, what if I do... Okay, so let's just say I don't do this. Don't do this. I'm curious, how much slower does this get? If I don't compress the graph, so to speak. Oh, actually, it's not. It's not. It's not really that much slower at all. That was a 4.85 seconds versus. Versus what? I mean, it's basically equal. It's basically equal. So really, I don't know if this is even worth it. This is just confusion. Hmm. I don't know. I might have to go to the Reddit because I'm not sure what to do to debug this. I mean, I can print out my circuits map, but that's not going to be particularly helpful. Um, Dude, day 8 has got my number. I tell you what. Just start from scratch with another approach. The only other way I'd know how to solve this is we literally have to build up each circuit individually. But then I don't know how I would validate that circuit's correct, in a large input. Um, yeah. I don't know, man. I don't know. I might have to go to the Reddit. Oblivious, I'll ask something to maybe help. When you add together the size of two different circuits that were merged, does the size increase correctly, accounting for each box already been counted? I was multitasking, so I might not perfectly up to date with your algorithm, but just food for thought. No, I appreciate that. So when you add together the size of two different circuits where merged, does the size increase correctly, accounting for each box already been counted? It should. Yeah, I mean that's probably a good point. There's probably opportunity there for some double counting. Huh. I think it does. But now that you say that, now I'm thinking, okay, maybe it would be better to just build up the individual circuits, because then I would know for sure that each junction box can only exist in a single circuit, right? So it would be very clear to me if I was somehow merging, or if I was putting a junction box in more than one circuit, you know. And it would be something that I could actually debug and check. Yeah, that might be the way to go then. Well, damn it! I thought this was gonna. I thought this approach was gonna work. Well, I guess actually, hold on. To this line of thought, it's still possible for me to figure out the list of circuits. I just have to process that map, right? So let's do. So we'll say, okay, for I'm going to put that back in. And I'm going to say for what? What am I going to say, Steven? Before we do any of this is fine. So let's do debugging. So in here, what we're going to do is we're going to say for. Let's actually do circuits equals a map that is going to be I literally just forgot how you declare a map. Yeah. So this is going to be a map. It's going to have a junction box key that is then tied to a list of junction boxes. And then we are going to say for each not connection, I guess, but for each box. Yeah, for each box in our boxes, we want to find that box's root, right? So this root is going to be equal to the finding of the root, passing in our box, passing in our circuits map. And then from there, we are going to set our circuits equal to that root. And we're going to initialize an empty slice like this. And then we're going to start to basically see. Oh no, we don't want to do that for it. Do we want to do that for everybody? I think we want to check first, right? So we want to say if nope, not that. Not that. So maybe we want to do existing. Circuits at the map of the box. We'll say if existing, like that. Then what we're gonna do is we're gonna say, okay, if you're existing, we want to, or if you're not existing, then we want to set you. Right? Yeah. And we want to set you to an empty slice of junction boxes. Otherwise, or I guess regardless, we want to initialize it, and then we want to add the box to it. So we want to say and if we get down here, then what we want to do is we want to do circuits equals circuits dot append. And we want to pass in our box. And we want to then update that root. So we'll say circuits root equals circuit. And then we'll do format.println the circuits. So theoretically what we should be able to see when we run this, not .NET, go test run solve part 1 with example input. Oh damn, because that succeeds. Hold on. Can I pass? I think I can get, if I pass -v, do I get print statements? There we go. So here's our map. And I think we need to print this in a different way because I can't make sense of that. So let's loop over. Where am I? Yeah. So let's loop over this and we'll say for KV range over circuits. And let's say format.println. This is our K and this is our V. Let's see if that is even easier to figure out what's going on. So this one's gonna, that's the thing, is like this one's gonna work. So I guess our theory, the original theory we had when we started doing all this debugging was Jaroslav. Thanks for subscribing, man. Our original thought when we were debugging is, hey, we are counting junction boxes more than one time in the circuit. That's kind of what our thought was. So what we're doing is we're actually building up those circuits. Yeah, we're actually building up those circuits. So what do I want to do? I guess what I want to do is I want to figure out if I find the circuit more than once. Right? And so how would I do that? Well, I guess the way I would do that is I guess I would count how many times it appears, right? So let's remove some of the... So we have our circuit. Now we need to loop again, and we need to say, okay, great, we have our circuits. So for each box, right? Let's go over our boxes again. And what we're going to do for each box is we're going to count how many times it appears. So we'll say appearances. And we're just going to start for each box, we'll start that count as 0. And then we'll loop over our circuits. In this case, we just need the values. So range over our circuits. And we basically want to check to see if the box appears in this particular circuit, this list of junction boxes. So I know this is very nasty, but I'm going to have another loop here that says for the B's, IB, range over V, right? And we want to check and see, hey, if B equals box, then we increment the appearances, right? And then after every circuit, we should just check to see if appearances is greater than 1 format print line junction box used twice. I think. So we're saying, okay, for every box, check it against all the circuits, and if you find the box in a particular circuit, mark that you saw it, and then after each circuit that you check, make sure that the appearance is not greater than 1. And if it is, then we saw it twice. That's the logic I'm using. So this should never print anything, which is good. This one, however, let's see what it does. Okay, it never print anything either. So that's not it. So we're not counting. Okay, so then if that's the case, so if we're not counting it twice, then I guess let's compare the length of the built circuits versus the circuit sizes that we calculated. That's, I guess, a helpful exploration. So let's do 4 V range over circuits, and we're just going to print line the length of the circuits, which should match the sizes. I say should because so do V, because I don't actually know. So let's also print down here format.println like that. Now these are going to be sorted, but maybe at a glance we can see what's going on. I don't know why day 2 is just or day 8's giving me so much problems, man. It's terrible. It's absolutely terrible. I guess I should probably sort these, huh? Oh, interesting. I don't think I see the same numbers. So we're printing the length of the circuits. And we're printing the circuit sizes here. Oh, we should probably sort these. Let's print this sorted. And then let's also do this code is just so messy. So I don't think these are the same sizes. So circuit lengths. So we'll do circuit length, dot append, the length of V. And then let's sort this the same way we sorted these down here. Why they wouldn't be the same, I don't actually know. But there must be a, if they are different, then there must be a flaw. Which is weird because it works for the input, so it's, I wonder why it's flawed in such a way. 61, 59, 51, 51. Yeah, I mean, these are significantly different numbers. Okay, so let's try these three numbers together and see what happens. So what's 13? 13 times 12 times 12 is 1872. 1872. Sanjay, thanks for subbing, man. Appreciate it. Stranger001, thank you for subscribing. I appreciate it. That's too low. Interesting. So there's either a, I mean, there's a issue with one of my two things. No clue if this helps. Hold on. Also for debugging, I recommend printing each edge with the roots index. So like a list, tuple, circuit 1, circuit 2. Then you can use your input, but start at the two shortest distances and increase one by one, making sure it matches your expectation. Oh, that's a good idea. Man, that's so painful though. Yeah, that's a good idea, but it's so painful. But I don't think I'm going to be able to solve this without. So what do I get if I don't? Okay, so let's do go test with the example. Well, that's interesting. So all of these should add up to I guess that's an interesting check, right? Is if we sum the lengths of the circuit, I'm kind of, now at this point I'm just kind of throwing shit against the wall to see what sticks, but I have met my match, that's for sure. Two? No, that's not right. Oh. Whoopsies. It would help if I used the right operator. Yeah, 20. So this should always sum. Now the reason why this is longer, there's a good reason for this. The reason why this is longer is because each entry in here represents a single junction box. And then that we're in this list, we're keeping track of basically the junction box that's tied to it and the size of that junction box. So it looks like our size is a little off in this case, but I do have an interesting check that we can do now. So basically we should be able to say if the total does not equal the length of boxes, we have an issue. There are more boxes in our circuits than we were given boxes. Just kind of interesting. Now let's try with the test input. Okay, so let me think about this. Why are these numbers, why are they so significantly different in the... I'm guessing there's some mistake that I've made that has magnified the more inputs that were given, right? Which is why the delta between what we end up in the lengths array and what we end up with here is not right. However, when we tried these three numbers multiplied together, they said we were too low, which is interesting. Yeah, 1872. We tried that, right? We did try that. That was too low. I wish it would show me the numbers that I had tried. Yeah, that is too low. So 1872 is too low. So that's which is fascinating because oh shit, man. The problem is I didn't implement this in a way that makes it very particularly easy to debug, because I'm not really ever building up the complete circuit one at a time. I mean, I do it after the fact, but I don't do it. Well, sheesh. It's already almost 6 o'clock. We might take another L on this day. And then we'll fall 2 days behind. Your first answer was closer for sure. I think it really came down to 1 or 2 start or end edge cases. Yeah, I mean, this is definitely in years past. This is where I would go to the Reddit thread, because I don't quite know. I don't quite know if what I've done to solve it is even a good thing to solve it. I guess let's do total. What I'll probably do is if I can't figure this out before the end of the stream, I will probably spend some time today at some point reading through the Reddit thread and trying to figure out what exactly I've done wrong. And then when I come back tomorrow morning, I'll just try to explain what it was that I didn't understand and what I learned, and then we'll move on to day 9, you know? Let's see. I want to print this. Would you like to hear what technique I applied to solve it? I think your algorithm is close enough. It could give you an idea. Yeah, sure. I would, yeah. I'm at the point, I think, in this where I don't know what to do differently. Well, I guess I do know that I could try to solve this in a. Okay. The problem is Steven is now getting frustrated. He doesn't want to rip the guts out of everything he's written and start from scratch. But that is the next thing I could do, is just start from scratch. Sharon Ram, what are you trying to build? We're not really building anything. We're doing I don't know if you've ever heard of it. It's called Advent of Code. I just put the link in the chat. We're doing Advent of Code this December, which is basically like every day they give you a problem, kind of a leak codey style problem, and you try to solve it. But it's kind of wrapped in like holiday themed stories, right? And today's problem, right? It's actually yesterday's or for me it's yesterday's problem. We're trying to solve day 8 part 1, and then we also have day 8 part 2 to figure out, which is wonderful. We've completely fallen off pace at this point. Okay, I just wanted to make sure that I was actually looping properly when I was going through my connections. So if I can't, okay, let's set that aside then. Basically, I have the same start where I make sure I have an edge between every unique pair of boxes. Then I gave every box a circuit ID. Okay. And as I iterated through the descending sorted list, I applied the left-hand box's ID to the second's circuit ID. Okay. Those IDs can then just be counted. Okay. I probably have to read your code to fully understand, I think. All right. I think we're at the point now where this don't work, and I'm not sure what to do. So I guess the other idea I had to solve this was to basically do much of the same. So let's make a new function really quick. Solve part 1 again. I didn't need to type all that again. So basically this is all the same. This is just parsing the boxes, getting the number of boxes, creating our connections, and then sorting them, right? And then this is the same here. Hey, Stefan, what's up, man? I'm decently proud of it. It doesn't feel very well optimized, but it solves it almost instantly, and I'm sure I could find shortcuts in my code. I don't think I totally understand what you did, though. So you have this, so basically I have the same start where I make sure I have an edge between every unique box. Yep. Then I gave every box a circuit ID. Okay. Was your circuit ID just a random number, or was it just like 0? You started at 0, 1, 2, and as I iterated through the descending sorted list, I applied the left-hand box's ID to the second's circuit IDs. Yeah, it's just enumerated for my boxes list. I Okay. Wow, that seems way simpler than what I did. Okay, so you're saying for every connection, because you're basically just building up the size list, right? Okay. Well, okay, so let me try that approach then. Cuz that I think I can wrap my head around that. Hold on, let me return 0. I have an edge between every. Yep, okay, then I gave every box an ID. Okay. Okay. Sure, thanks for subscribing, man. I appreciate that. It's very kind of you. I guess I'm not sure. How did you resolve Oblivious? How did you, when you say, then I iterated through the sorted list and I apply the left-hand box's ID to the second circuit IDs. Let's see if I can draw this. So every box gets its own ID. Okay. And then obviously you have a connection that you're looking at. Oops. You have a connection that you're looking at. Basically, if you have boxes in ID 1 and a new edge is found, I make sure that any boxes within ID of the second box is now updated to the first box's ID. Now they're all the same ID. Hopefully this explanation breaks down. You know, you're probably doing a wonderful job of explaining it. I'm just too dense to... I think I see conceptually what you're doing. Okay, let me see if I can't stumble my way into something that mimics what you're describing. Right? Okay, so I'm gonna do this. I'm gonna say for Oh, you got a schnauzer? Who's got a schnauzer? I love schnauzers. That was my family dog all growing up. Yeah, schnauzers are such good dogs, man. That's actually one of my like bucket list items. Is before I die, I want to own a giant schnauzer. Turkish Kangal. I don't think I've ever heard of that dog before. Wow, I just about spilled my Gatorade everywhere. I guess the problem I'm having a hard time understanding is if I do this like this, so let's say if I loop over every I box range of boxes, right? And if I create a circuits, right? And I say map of int to junction boxes. And I say each circuit gets an I. We set that to I have no idea if this is what you actually did. You actually did. Oh, doesn't exist. This means, what does this mean? Well, this means every junction box starts its own circuit. And I say, yeah, so this is where I guess I don't know how to do this without just brute forcing over the junction boxes. Fuck it. I'm just fuck it. I'm just gonna. I don't care. I'm just gonna brute force this because I don't know. So you said you always applied the start. Nada, thanks for subbing. Yeah, that's fine. You can send it over to me. I'm gonna still try to keep working through this without necessarily trying to completely outright be told how to solve it. If I get to the end of today, like if I get to the end of, if I get to midnight tonight and I still haven't figured that out, then I'll just look at someone's solution and we'll move on to day 9. Because clearly I found kind of the edge of my abilities in some extent here, right? And I've struggled now for almost, at this point, I think we're up to like 4 hours now of struggling on this. Schnauzer's going after cats, nice. Well, you would want it to be junction boxes to int, or at least int to list of junction boxes. Yeah, but that's where this seems not optimal, right? Because I guess my thought is now I have to look through each junction box to figure out. I have to look through each list to figure out if the start is in there. I think it's hard enough using Go. Then using Go for this problem is too complicated. Yeah, maybe. I don't know. I think it's more of a skill issue on my part. I think conceptually I understand it, but I think I'm also getting a little hung up on trying to do it in a non-slow way. But at this point, who cares how slow it is? Like, if I have to loop a bajillion times, so what? At least I'd have an answer. Um, and that's okay. I mean, that's part of admin of code, right? Part of admin code is testing yourself and trying to find what you don't know and what you do know. And good morning, Nelson. How are you? Good to see you, dude. It is 6:11 though, and I haven't made coffee, so I think I'm gonna make coffee and then we'll spend some time on this, some more time on this. So give me 1 sec to set that all up. Excuse me. I'm not actually leaving, but just so that you guys know where I've gone. Oh goodness. All right, to the coffee station. There we go. I also need my brain chat. I'm very frustrated that I can't figure out day 8. I mean, I'll figure it out. I'm frustrated that I can't do it without a bunch of suffering. Let's see, we're in Panama today. Interesting. I don't think I've ever had coffee from Panama. Let's see that. Yeah, I've never been to Panama. I don't hear much about Panama myself, but I've never had coffee from Panama, so that's exciting. Yeah, coffee cam. I've been calling it the coffee station. while the water finishes boiling, I'm gonna go to the restroom. I'll be right back. Hey, what's up, Unique UX? Good morning. Martian play what do bro work for, or what work do you work as? Why is he coding now at home? If you're curious, you can check out my LinkedIn. I'll put that in the chat. I work as a quality engineer. I work for a small company in Kansas City. Just write code at home for fun. My LinkedIn's there. You're welcome to creep on my LinkedIn as much as you'd like. You can also send me a connection. I'd be happy to connect with any of you guys. It's always nice to meet other people who are working in tech. Alright, we'll let this steep. We'll come back and get it in a couple minutes. Excuse me. some big old burps today. All right. Don't let me forget about the coffee. All right. Okay, so we had abandoned our previous solution because I don't know how to fix it. And now we're trying to think about how we could do this in a simpler way with the hints that Oblivion gave us. And I don't know. See, the thing that I'm having a hard time wrapping my head around is each connection has a start, right? And obviously it has an end. And so what I want to do is, if I'm following your logic, what I want to do is I want to apply everything from the right, the connection from the right to whatever the start's attached to already. But I think that's where I don't know about you, but that's where I think that this makes more sense for this map, for the key to this map to be an entry. My logic kept as minimal as possible. There's only a distance, each box, and a circuit identifier. Yeah. Yeah. I guess, yeah. I don't know. I think me and yours brain might just conceptually be thinking differently. Again, it's like if I went and looked at your code, it would probably make way more sense, right, than trying to think about a complex algorithm in YouTube chat. So but I'm trying to avoid doing that because I know as soon as I look at someone's code, I'm going to have the answer and I'm going to know how to implement it. And I'm trying to avoid doing that because if I can figure it out for myself, that would feel the dopamine I would get from doing that would be so much better. You might have gotten caught up a bit on the phrasing. It was definitely having me double checking. No, you're doing fine. No, it's not you. It's definitely not you. It's definitely me. I'm referring to the day wording. No, I mean I think I understand the problem. I think I understand. I'm pretty sure I want to make the 10 shortest connections, right? But the problem is sometimes the shortest connection results in a circuit that's larger than 2 boxes. And you need the total size of the connections, right? So to me, that's the tricky part. The tricky part is when things have to be put together. And so that's why you have to keep track of, in my opinion, to some extent, what you have to keep track of is you have to keep track of the node, the root, the starting node, in my opinion, and then the connections that were made to that thing. And I think if I'm following kind of the way you described it, I guess my thought is if I have a map and the key to my map is the root of a circuit, in this case, like the starting point of a circuit. And for each connection, then what I could do, why is it airing there? I guess my thought is then what I can do is I can say, okay, great. Well, let's find the current So if we treat the start of every connection, let's say start circuit equals the circuits at yes, exactly. Abdul, thanks for subbing. Man, we've had a lot of people sub today, haven't we? Blackie Chan, thanks for nice username, man. Thanks for subscribing. Man, we've had a lot of subscribers today. This has been a lot of stream alerts. I don't think I've kept up with them all either, because I've also been filling. Oh, coffee. Shit. I always do this. I sit back down at the desk. Maybe I should just stop sitting back down at the desk. My first coffee from Panama. Never had one before. The tasting notes are blackberry compote. I don't even know what that is. Dark chocolate, raisin, and spice. I don't know how I feel about the raisin, but I can get on board with the rest. I never actually think the tasting notes line up with what I'm actually tasting, but again, that's probably a skill issue on my part. Skill issues abound the last couple streams. Lots and lots of skill issues. Good morning, honey. I'm gonna lock in, okay? I'm gonna lock in. Okay, but let's print state with each connection then, so we can check if the first 20 are adhering to the given constraints. Okay, yeah, we can do that. We can do that. So the start circuit is going to be the connections end, and the end circuit excuse me. Whoops. This should be start. Okay, great. So what does this mean? I guess what this means is yeah. I mean, so basically the way I've set this up is these are guaranteed to always return something at the beginning, right? Because I've initialized my circuits map. And so now I need to figure out what I want to tie to what, right? And so I think if the length of the start circuit equals 0, we know this is like the very first thing. Right? Hold on. I'm gonna print some of this. So let's print, and let's only do one connection. But we also need to add a test for this. Man, this is so freaking hard. I keep thinking, man, I still have part 2 to do. That's what I keep thinking to myself. Test solve part 1 again. Why is that complaining? Oh, whoops. Just rewarding, but it means you can track a group of boxes and tie the end circuit to the start circuit. Exactly, yes, that's regardless if it's a lone box and its circuit or a whole multi-box circuit. Yes, that is what I want to do. Sorry, I just got a text message. Make sure it's not from my wife. My wife is sending me jokes. Okay, so we're here. Going back to my tests. Yeah. So we still expect this to be 40. I mean, that's not going to change. Yeah. But can I do that? I think you got it then. I'll go get breakfast myself. Still watching along. Yeah, go. Yeah, enjoy your breakfast. Don't worry about me. I'll be happily here struggling. The thing is, though, I don't think I can just blindly attach. I mean, can I? I mean, I guess that's what I'm saying, is I'm saying I can just blindly do this, where I basically do an append the start circuit, the connection end, and the end circuit. How do I... Oh, we probably need to loop, don't we? For the range over and then do circuits dot connection. Oh, sorry, circuits at connection start equals start circuit. And I guess let's just do this. I think this is though going to end up with multiple. Let's see, format. Print line. For key v in range over circuits, format print line, the K and the V. And then instead of test with example input, we'll do test solve part 1 again. One, two, three, four. Okay, so does that sort of kind of work? So if we do, real quick, if we format dot print line, the K and the V, which actually what we want to do is I actually want to print the length of V plus 1 because our key is not included in the adjoining boxes. So let's see what the length of these things are. It should be 5, 4, and 2 or something like that. 5, 4, 2. So I'm pretty sure there are places where boxes are getting put in there more than once, I think. But excuse me. If no, okay, so that never happens. I guess what I could do is I could okay, I'm just gonna do this in a very dumb way. So we'll just do sizes. Yeah, so I need to add, I have to add 1 to count for the key that's not in there. And then I guess we'll just, again, we'll sort slices dot sort func. We'll pass in our sizes. We'll declare a function that is a int, b int, returns an int, returns b minus a, and then we'll print the slice sizes again, which brings us to 5, 4, 4. Yeah, see, this is wrong, right? That's not right. So something, also, if it helps, part 2 shouldn't be much extra work. Don't remind me. Don't remind me that I have a whole nother part. Okay, so something's happening where okay, so to who was it? It was Renee. Renee was like, okay, so print it out on each iteration. So I like that idea. So let's do format.println. And then let's do 4 kV range over the circuits. We'll just format print line. And this is the most printf debugging. This advent of code is the most printf debugging that I've ever done during an advent of code. And it reminds me of why debuggers are so fucking awesome. Okay, so let's see. Connection 0. Okay. Connection 1. So technically, right? I'm just gonna talk out loud. Technically, now that 425.69.689 is here, and it's connected to this box, or it's included in this circuit, it can't have its own circuit, right? Well, I mean, I guess it can. Yeah, it can. Yeah, something could make a connection to 425, right? Something could connect here. And that's where it needs to then flow up. So that's the part that this doesn't make sense to me, is because it needs to, if something connects to 425, it needs to know that 425 is connected to 162, and therefore it now is connected as part of this circuit. And I don't think that's happening. So what did I just say? So what I said was, what did I just say? What I said was, is when we come down here and we get the start circuit, this is totally fine to do, but it could be that the connection starts is already contained within a circuit somewhere. Which to me is why this data structure doesn't represent the problem well enough. If that makes sense. Let's see, what do we end up with? What's our final iteration look like? So our final iteration here, connection 19. That's our final iteration. I'm trying to find like duplicates. Yeah, here we go. So look, you got a junction box here, and you got that same junction box up here. It works if the key is the box and the value is the circuit. Yeah, but I don't, for whatever reason, I don't see then how did you deal with this type of circumstance? So how did this end up in two places? So it got connected to this thing, and then I'm guessing there was a connection between these two, right? But basically, whenever we have this connection, or whenever we have this connection, when this thing and this thing, when we process that, we should have known that this is actually tied to this already, or vice versa, one or the other. Okay. Let me think for a second. If I was actually gonna build up the circuit, what would it look like for me to do that? And I think what it would look like me for do that is I would actually do some sort of breadth first search over the. So let me. Okay, so I'm gonna back up here, and I'm gonna try this. Since we're already going to down the path of not optimal, then fuck it. Let's just embrace not optimal, and we are going to have circuits which are going to be essentially a list of lists. And we are going to keep track of places we've been. So we're going to have a map, and we're going to call this visited, right? Or good old, what's it, map? And map is just going to be a junction box, and we'll just make this a bool. It's just basically, this is almost like a set, essentially. This is how I would use a set in like JavaScript or TypeScript. I'm just going to use a dictionary. And I'm going to go over each box in our boxes. Maybe I'm just getting too comfortable with BFS, and so I just apply it to everything. So we're going to say if visited contains this box. We've already been here. Whoops. Oh goodness, we've already been here. So move it along, right? And then what we're going to do is we're going to while loop. I know we're going to not while loop. We're going to for loop inside a for loop, which is wonderful. I know. And in our for loop, we are going to do something like this. We're going to say our current circuit looks like this. This is our current circuit. And then we're going to have our queue, which we actually have a queue. So we can actually say box queue. So we can use our queue implementation from earlier in Advent to code, and we can say new, and this is of type junction box, like that. And we'll just, first thing we'll do is we'll add our box to it. So we'll say box queue dot in queue for box. Oh, whoops. And then while box q dot is. Oh, sorry, there's no while loop in. Go. For box q dot is empty equals false, we're gonna do stuff. And what we're gonna do is we're gonna dequeue whatever's in our queue. So we'll say current equals box q dot dequeue, and we'll just ignore the boolean because we don't really care. I have a dictionary of all boxes with at first each their own circuit ID. Then I update all the keys to have the same value to another existing circuit by updating. So maybe, yeah, that's probably the part that I was missing, was I wasn't updating. I wasn't updating the other things. But to me, I'm just going to process through this iteratively. So I'm going to say current circuit dot append current, like that, and then what do we do? How do we get the next one in the list? I think that would be great. Visualization would be awesome. I don't know, man. I'm so lost. Hey, Noki, what's up? How are you? Good to see you. Welcome to my never-ending day 8 Advent of Code nightmare. Julian, thanks for subbing, man. Appreciate it. I think I'm missing an piece of information. So what if I do this? What if I do this? What font am I using? Hey, Julian. I'm using Cascadia Cove. I can show it to you. I'm using a nerd font. It's called Cascadia. Actually, I think I actually have it set up as a link in Stream Elements. But if you go to nerd font, yeah, there you go. There's a preview. That link will take you to a preview. But it's called, the name of it is called Cascadia Cove. Yeah, this one. That's the one I'm using. Noku, how's admin of code going? Well, it's not going super well. Julian, I'm also doing admin code right now. Just finished half of day one. Dude, day one was rough, man. Day one was like next to day 8 so far was equally challenging, equally difficult. So hang in there if you're having any troubles, but okay, I'm gonna do this. Okay, let's walk this back. So at this point we have connections, right? That's what we have. At this point we have connections, and they are sorted. And so I think what I'm gonna do is I'm going to build up a list of, I'm gonna call this neighbor. I don't know what the right term is here. I'm gonna call this neighbors. And this is going to look very similar to the last thing we just were working with when we were following Oblivious's idea. And what we are going to do is we are going to iterate through our connections. And we are going to say connection equals range of connections. And we're going to say, okay, great. And we're basically going to do a very similar thing that we were doing where we say if, hold on, neighbors, or I'm going to say start neighbors equals neighbors at connection.start. So this is basically exactly what we were just doing a second ago. And so what we're going to end up with is if, let's see, start exists, end exists. And we will say if start exists equals false, then we will initialize it. And if end exists equals false, best of luck in day. I appreciate that, man. So far, it's going absolutely horrible. We're still working. We were supposed to be done with part 1 yesterday, and we are not done with it. But we're staying strong. We're staying strong. You know, we're trying to keep a positive mindset here. So this will be neighbors at connection start is going to equal I don't think I actually need to do all that, right? Like I can just do what we did earlier, which is for yeah, let's just outright initialize everything. I know it's another set of iterations, but at this point we have left optimal way back down the road somewhere. So neighbors at box equals an empty slice of junction boxes. Why can't I use that? Cannot use box. Oh, that should be boxes. So now we don't need to worry about if it exists or not. And what we can do is we can just blindly put things in the list, right? So this is where we can say, great, wonderful, start neighbors will be dot append, and the start neighbors are going to append what? We're going to append the end. Yeah, the end. And then end neighbors are going to append the connection dot start because it's not a directed graph. And after all of this, we should end up with something like a let's see, for neighbors. Or sorry, hold on. This should be KV range over our neighbors. Just format print line K and format print line V. Oh, yep, we're not using pointers, so we have to actually do a reassignment here on the indexes. So we have to say connect neighbors at connection start equals start neighbors, and then connections end is end neighbors. Okay. See what this looks like. That seems like way too much shit. Well, yeah, that's dumb. You're going to end up with... Oh, is that because I need to limit this? Okay, yeah, that's more of what I was expecting. So then, with this in place, so if these are our neighbors, we should be able to then process this into this. We should be able to process this list, or this neighbors list, into the actual circuits, which is what I'm trying to do. That's it. At the end of the day, what I'm trying to do is I'm trying to actually make a complete circuit, is where I'm trying to get to. And the reason I'm trying to do it this way is so that it's easier for me to maybe spot the issue in my actual input. That's the idea. What's up, Gunheist? Oh, you're still alive? Yeah, I'm still alive. I'm gonna try to wrestle with this for a little bit. I'd really like to try to finish this, at least part 1 today, the best I can. So I think now what I can do, since I built that up, I think now I can go back and actually try to create the circuits. So a circuit is just going to be a list of lists, again, of junction boxes. And then this will be our visited. Yep, just like we had visited, which is a map. And that is just there to make sure that we don't visit things more than once, or we don't use a junction box more than once in a particular circuit. So then we'll say for box. Oops. Wish I didn't have to discard the index like that. Range over boxes. Whoops, this should be box. Then what we'll do is we'll use our neighbors list to actually create the circuits. So this is where now we can say if visited contains this box, we do not want to process it again. And then we are going to do our actual, so we'll do current, or I guess let's do current circuit is going to be a slice of junction boxes. And we'll have a queue, we'll have a box, a junction, let's find box is a queue, which is going to equal queue dot new, and this will pass in our junction boxes, and then we will in queue our current box. So box is queue dot in queue box, like that, and then for as long as boxes queue is empty as false, we're going to process. Yeah, right? We're going to process. And so this just turns into a breadth first search where we're going to dequeue the item. We're also going to mark the box as having been visited. So we're going to say visited at box equals true. And again, there's no triple equal sign and go. I keep doing that, man. 199. I applied for an internal role at work and they're already panicking. Why are they panicking? Just because you want to move teams? PL0X420. What's the favorite thing you ever coded and why? I built a background removal tool this year and a Discord bot this year, and both of those projects were a shit ton of fun. Yeah, those were a blast to build. The background removal tool was a lot of fun because it solved a problem I had and saved me money, you know? And then the Discord bot was a lot of fun because I didn't actually think I was capable of implementing the Discord WebSocket protocol, and I actually implemented the kind of the connection logic. I don't know if I did it perfectly, but I did implement it and it works. And my Discord bot has been up and running for like weeks on end, months on end now without ever crashing, which is pretty cool. Yeah, pretty much I know a lot about what I'm doing, but don't want to continue here. Oh, I feel you, man. That's tough. It's tough. But you gotta do what's best for you. You gotta do what's best for you in your life. It's either I apply and move teams, or I go somewhere else in the new year once I get more solid with coding and pivot entirely. I get it, man. You gotta do what's best for you though. It's your life, you know? It's your life. You're the only one who has to live it. And so you should make your decisions accordingly. Good morning, hi. Good to see you again. Thanks for stopping into the stream. Appreciate you. Let's see. Now we'll do current is going to be equal to boxes q dot d. I should have just done this. This is how I should have done this problem the very first time around. I shouldn't have tried to be clever with it. I should have just focused on how do I build the circuits. That's what I should have focused on. So current circuit is going to be appended with the current box like that. And we're going to ignore the potential Boolean return value. And then we are going to say this circuit has what neighbors? So this circuit has, or not this circuit, this box is connected to what other neighbors, right? So this is where we're going to say current neighbors is going to be equal to the neighbors map at this particular box. Now we're going to iterate through each neighbor. And we're going to first check and see if it's already been visited, because we don't want to double visit it. So we'll say if, if visited contains in, sorry, lagged out for a second, then we continue. Otherwise, we are going to set it, so we'll mark in as true, and then we will push in onto our queue. So that's where we'll say queue, or sorry, boxes queue dot on queue in. Then after that's all said and done, we need to actually take the current circuit and we need to add it to our circuits list. So we, at the very end, can actually have it done, right? And where do we do that? We don't want to do that in current neighbors. We don't want to do that in, I'm going to do that down here. So this would be circuits, append the current circuit, like that. And hopefully this won't end in an infinite loop, but let's print line the circuits. Right? Actually, let's loop and print them. So we'll say for I C range over the circuits and format print line I C. So hopefully, I know there's a lot of looping going on here, but basically what we're doing is we create our connections first, then we generate a neighbors map, which is basically saying this junction box is connected to these other junction boxes. Then we're actually using the neighbors, that map that we made, to actually build up essentially the individual circuits that exist there. So let's see how that works. I'm guessing it's not going to be particularly performant. So there's 10. And you can see there are some single ones. Okay, so then let's also print the length of the circuits, like that. And we should have 5. We should have 5, 4, 2, multiple 2s, and I think the rest are 1s. We should have 1, 5. We should have 1, 4. I think we should have had 3 2s, right? No, 2 circuits which contain 2 junction boxes. Okay, so this is so this is correct. This is correct. In other news, I got a visualization done. Nice. Well, I can't wait to see it. I can't wait to see it. So actually, Oblivious, the thing you gave me actually was super helpful, because I basically ended up using that idea to basically make a data structure that then I can process into essentially what our circuit graph. So thank you very much, Oblivious, for your help thinking through this problem. All right, so now we have the circuits. So we need the sizes. So we'll say circuit want to be dumber, start VLANing. I don't want to be dumber. I want to be smarter. You know? I want to get better. This will actually make this way easier to debug too, I think, because now we actually can visually see what circuits we have. So let's do the length. Yeah, so we'll do circuit sizes. Stop. And the length of C. Then we have to sort it. So I already have that up here somewhere. So we'll do, whoops, I jumped way too far down. Going to be return B minus A. And then same thing here that we did in part 1. We'll just panic if we don't have enough circuits. Otherwise, we'll just return those. I'm curious. I'll be really curious to figure out why my first run, though, didn't work. You know, I'd love to spend some time thinking through, like, well, why did my first problem solve the example but didn't solve the input? Okay, that passed. Now let's see what happens when we use this new approach for the actual input. So we know, we know solve part 1 again. All right, moment of truth. It needs to be, we know it needs to just be a lower number. It's going to fail, but we'd like it to be a lower number. Oh, it was lower. It was lower. Oh my goodness. Okay, guys, cue up the drum roll. Cue it up. Hold on one sec. Let me get it. Let me open the drum roll sound again. The first time I did this, it was very anticlimactic. Yay! Let's fucking go! Oh my gosh, bro. Yes. Dude, that was such a fucking... Oh my god. What a fucking nightmare that was. Bro. Oblivious, thank you so much for being encouraging and helpful and trying to nudge me in a better direction. Thank you guys. I appreciate you guys hanging out with me and keeping me company through all this. Very nice. You want a coffee? I do deserve a sip of coffee. Okay, what are the odds? It's 723. What are the odds that we can solve part 2? Gosh damn, I'm so glad that I wanted to give up. I wanted to go to Reddit so bad. Like I was like, let's just go ask Reddit. Reddit knows everything. Those guys, the people in those Reddit threads are fucking geniuses. Let's go. I am gonna keep the other solution there though, because I'd like to spend a little bit of time examining why my other, now that I know what the right answers are, I'd like to spend some time figuring out why my initial approach failed. And I'm guessing it's going to be very obvious whenever we get there. We need to re-download the problem now. So let's do AOC, download, day 8. Frustrating day today since my boss has been gone. Ah, dude, that sucks. That sucks. I'm sorry your day's been frustrating, man. But I'm glad you're here with us right now. Oh, my day was... I was very frustrated. Up until 30 seconds ago, I was ready to rage quit this whole fucking event. Where can I share the visualization? Do it in Discord. Yeah, I mean, if you want to do it in Discord, I would love to see it. What you did. There's a production issue and I'm the only one who can fix it. My coworkers don't know how to do anything, only know how to produce AI slop and close tickets. So what, you work with a bunch of vibe coders, Minister of Defense? That sucks, man. I'm really sorry. I wish that wasn't the case for you. All right, part 2 is the elves are right. They definitely don't have enough extension cables. You'll need to keep connecting junction boxes together until they are all in one large circuit. Continuing the above example, the first connection, which causes all of the junction boxes to form a single circuit, is between the junction boxes at these 2 locations. The elves need to know how far those junction boxes are from the wall so they can pick the right extension cable. multiplying the x coordinates of those two junction boxes produces 2, 5, 2. Continue connecting the closest unconnected pairs of junction boxes together until they're all in the same circuit. What do you multiply together the x, or what do you get if you multiply together the x coordinates of the last two junction boxes you need to connect? I don't know if I understand. So Okay, let me just explore something really quick. So if I right now we're limiting the connections, and what he's saying is, well, you just want to keep connecting things. You just want to keep connecting things until everything is in a single circuit. Okay, so what happens if I'm gonna format print the circuits. So if I format dot print line, if I format print line the I and the C, right? Whoops, that's not what I wanted to do. Part 1 with example. Sorry, that's what I'm doing. I was like, I got way too much printed on the screen. So not all of these, they're not all ever going to end up in a circuit right now based on my current logic. Unlisted code logic, thanks for subbing, man. Appreciate you. Because I'm limiting the adjacency list that I'm creating. So if I do it for all the connections, and then I build the circuits, what do I get? A panic. Not enough circuits. Because I just have a singular circuit. And so what he's saying is I need to know what the final two are. So I think I have that information. Right? I mean I have that information because I can get to a single circuit. I just delayed netgoat to like 2 months because I'm rewriting it in Golang. Nice, Ducky Dev. That's a classic developer move. Project delayed. We're gonna rewrite. I'm going to just tell that Freeborn is the man for the job. I don't know. I don't think I'd fit in with all those vibe coders over there. Still can't decide between a 5080 and a 9070 XT for Fedora. I don't think I can help with that decision. But I would definitely, it was me, I would definitely go for stability. Um, I would definitely prioritize stability because unstable things are frustrating to deal with. Things that you can't rely on or can't count on, that's no fun at all. Um, so how do I know though? Because I'm doing this breadth first search. I have the neighbor, I have my adjacency list. And so at some point, I know when my circuits are being built. So let's do format.println circuits. So I only ever have one. And they're telling me, what were they telling me? They were telling me the elves need to know how far those boxes are from the wall so they can pick the right extension cables. So these are the last two that we need to connect. One seven. 117. Where's 117? 117, 168, 530. 216. So let's print format.println current circuit. We start here, start here. So this almost makes me think there's like a very specific way I'm actually supposed to solve this to be able to answer part 2, and I don't feel like I solved it in that way because I need to figure out that 216 You'll need to keep connecting junction boxes together until they're all in one large circuit. The elves need to know how far. Continue connecting the closest unconnected pairs of junction boxes together until they're all in the same circuit. What do you get if you multiply together the x coordinates of the last two junction boxes you need to connect? I've had more issues with NVIDIA on Windows than Linux nowadays, so honestly, whichever you will utilize most. I personally use CUDA on Linux quite a bit for compute. Nice. Yeah, I just think stability is important. Yeah, so whichever one gives you the most stability. I don't so I solved this, but I solved it in a way that doesn't help me answer part two. Or at least it doesn't seem like it does. I guess if I was doing, let's see, is there a way that I can move some of this logic? Neighbor's current. I've wholly run out of time. It's 7:38. I'm still off pace. I solved part 1, but I still need to solve part 2 for day 8, and tomorrow I need to be on day 9 part 1 to stay on pace. However, I will say if the furthest I've ever gone in Advent of Code in prior years, the furthest I made it last year was, oh shit, I think the furthest I made it last year was day 17 part 1 or day 18 part 1. I can't remember because we use these for practice problems. But I think in 24 days I solved 17 part 1 or 18 part 1. And in 13 I made it to 15.1. So this year, if I make it through day 19 or day 9, that will be kind of the furthest I've ever gone in the 24 days, basically. I've never actually completed one of these. All right, back to the drawing board then. I might try to stream a little tonight. I might try to hop on tonight after my kids go to sleep and try to work on part 2 of day 8. And if I can get day 8 solved this evening, then I'll be back on pace tomorrow. So that's what I'll try to do. Well, guys, I appreciate y'all sticking with me for so long. There's 60 of us here at the end of the stream, which is just absolutely fucking nuts. So thank you very much for hanging out with me and keeping me company. Oblivious, thanks for keeping me motivated and encouraging me. I'm going to do Tad. Hey, man, just curious. If you are a full-time streamer or if you have a job. No, I have a job. That's actually why I have to... That's why I need to wrap up, because I was going to try to go into the office today, actually, for some holiday stuff that's going on. I put my LinkedIn in the chat there if you want to creep on my professional history, but I work a 40-hour-a-week job, just like I'm sure a lot of you do. And I just do YouTube in the mornings or in my free time for fun. My stream schedule, if you're new here, my stream schedule is typically 4:15 to 7 a.m. most mornings. And then sometimes I'll stream in the evening, but typically my schedule is like get up, stream till about 7, go upstairs, see my kids, get everybody off to school, get myself ready for work till about 5 o'clock, then hang out with my kids from 5 to 8, then hang out with my wife from 8 to whenever I go to bed, and then repeat that. That's my general schedule most days. But I might make an exception for admins of code so I can try to get back on pace. If you'd like to check out the visual I posted. Oh yeah, I would love to. Let me see. Discord. Yeah. Yeah, I would love to. Oh, that's super baller. How did you make that? That's really cool. That is really, really cool. This was a oops, I'm showing it on screen. I was trying to make it full screen, but I guess I can't. This was a visualization of solving day 8. That's pretty cool, huh? I love that. Yeah, I'm gonna need to explore that visualization to whatever you use. I've never heard of it before, but I'm gonna have to explore that. Maybe I can use your visualization to figure out how to implement that, and that would let me solve part 2. Pretty busy schedule. Love that, man. Yeah, I mean, it's a busy schedule, but it's a great schedule. I mean, I enjoy my job. I enjoy the place I work. I love my kids, and YouTube's fun, right? It's a good time to talk to other people who are interested in the same things I'm interested in. Alrighty, folks, I'm out of here. So normal wrap up. If you want to interact with me or any of my chat outside of the stream, the best place to find us is in our Discord. Feel free to jump in there if you'd like to. No pressure. If you'd like to come back and see us, hang out with us again, like I said, my normal schedule is from about 4:15 in the morning to about 7 o'clock in the morning most weekdays, and then on the weekends I'll try to go a little bit later. So if you see me live, obviously stop in, say hi. I'd love to hear from you. Otherwise, maybe I'll see in the comments of a short or a video or something like that. And if I see some of you tonight, if I get on to stream, that'd be great, but no pressure there. And that's it. All right, chat. Stefan, see you, man. Have a good day. Appreciate you hanging out with me. Tad, have a nice day. Oblivious, as always, appreciate your uber intelligence and ability. It's very helpful. 199, have a good day, man. I hope you make a decision. Ducky Dev, good luck with rewriting NetGoat and Golang. Sounds like a blast. Filthy Potato, sorry, I just saw your message, man. Sorry I missed you 20 minutes ago. Hope you're doing well. Hope your drive's going okay. Hope you made it there safely. Minister of Defense, good luck with your job. Good luck with the boss being gone. I hope it gets better. Gun Highs, if you're still here, have a good day, Gun Highs. All right, y'all. I'll talk to you later. Hey, Wilding Airplane, we solved part 1. Day 8, part 1 we solved. Day 8, part 2 is still on the chopping block, so we need to it's currently up to bat, and we're going to try to solve it. I might try to solve it a little bit tonight and see if we can't get completely back on track finally with graphs. Yeah, what I ended up actually doing was I ended up parsing the connections into an adjacency list, or basically a map of this junction box is connected to these junction boxes, and then I took that data structure and turned it into circuits, which were basically like individual undirected graphs, essentially. But that's what we ended up doing. So we'll try to but it doesn't help. The way I solved part 1 does not help me solve part 2, so I have to revisit that, unfortunately. All right, chat, I gotta go. Bye, guys. Have a good day. I hope you guys have a wonderful Tuesday. If it's already Wednesday for you, have a wonderful Wednesday. Bye, guys. Bye. See y'all. Appreciate you.